Hello friends, welcome back to my YouTube channel. Today I came up with one very important topic, that is Millikan's well drop experiment. In order to understand this Millikan's well drop experiment, its mathematical derivation clearly, at first we must learn four basic forces along with their direction. Now let us start the first part, that is some basic information, and in this part I have included weight. If we have to calculate weight of a spherical ball, then we must learn the volume of spherical ball, that is 4 by 3 pi r cube. Why I kept this information over here? Because in Millikan's well drop experiment they use a special type of well, and well drop is in spherical shape, and the volume of sphere is 4 by 3 pi r cube. As we know that expression of weight is m into g, and then mass can be calculated by multiplying density and volume. Volume is already 4 by 3 pi r cube, so weight of a spherical ball is 4 by 3 pi r cube rho into g, where r is the radius of this drop and rho is the density of this drop or of this ball, and weight always acts downwards. Now let us learn what is upthrust. Upthrust is also m into g. Upthrust always acts upward, and here mass is also volume into density, but density for upthrust is density of medium. So density of medium is denoted by sigma. In Millikan's well drop experiment we use air as a medium, so upthrust always acts upwards. Now what is the difference between upthrust and weight? Weight acts downwards, upthrust acts upward. In weight we use this rho as a density of object, and here we use this sigma as a density of medium. Now another force is viscous force. Viscous force, expression of viscous force is 6 pi eta rv. Viscous force is same like as friction. This is the friction or backward force or drag force of fluid. If object moves upward, this viscous force moves the direction of viscous force will be downward. If object moves downward, the direction of viscous force will be upward. In this way, direction of viscous force is always opposite to motion. It acts always opposite to motion. Sorry. Now let us see another force. This is electric force. Expression of electric force is Q into E, where Q is the charge and E is electric field intensity, that is V by D, where V is the potential difference between these two plates. If this plate is connected with one battery, then the potential of this battery is called V, and the separation between this plate is called D. Here the direction of electric force is always from positive to negative. In this way we made a basic information. We got a basic information. They are needed in this experiment. They are the weight, of thrust, viscous force, and then finally electric force. Now let us see the apparatus. So now let us learn this term, quantization of charge. Before moving to the apparatus, this term is very important in this derivation, quantization of charge. Quantization starts from this word Q, so I have kept Q over here, and N is term here, this N I kept N over here, and E is the last term of charge, so E is here. So quantization of charge is just Q is equal to plus minus NE. This Q is total charge present in a body. So total charge present in a body is equal to integral number of basic unit of charge. This is called quantization of charge. I have made separate video on quantization of charge as well. So here E is basic unit of charge, which value is 1.6 into 10 to the power minus 19 coulomb, where N is the integral number and Q is the total charge in a body. What is the importance of Millikan's well drop experiment? Millikan won Nobel Prize by doing this experiment. Now this experiment gave the value of electric charge, that is E is equal to 1.6 into 10 to the minus 19 coulomb. This is the greatest discovery of that time, and this experiment gave the concept of quantization of charge. We already knew that charge on a body is integral number of this basic unit of charge, which is called quantization of charge. So these are the importance of this experiment. It means this experiment gives the idea of quantization of charge and then charge of electron. Now let us see the apparatus. In this apparatus, Millikan did his experiment. This is atomizer and this is the reservoir where clock well is kept. We use clock well in this experiment because from clock well we can get small droplet, and clock well does not vaporize easily. And this is traveling microscope, and there are different windows. This is a source of X-ray, and we can apply different potential, different voltage between the plates. Now let us see this diagram like this. If you go inside this plate, then you will see this upper plate. Upper plate is circular plate and hole with a hole at the middle, so that when we pump this atomizer, oil drop will go over here and some oil drop will come from here, from upper plate to lower plate. And this is X-ray source. The function of X-ray is to ionize this oil drop. To ionize means to create charge on this oil drop. This traveling microscope, the function of traveling microscope, I have kept this figure as well. Function of traveling microscope is you see the oil drop and its position, and at the same time if we calculate time, then the distance traveled by the oil drop divided by time will give the terminal velocity of oil drop. So traveling microscope is used to measure the terminal velocity. Atomizer is used to spray the oil drops. This battery is used to create potential difference between upper plate and lower plate. There is source of light which makes the oil drop visible, because this is the apparatus in which we perform experiment. And in your examination you don't need to draw this all diagram. This diagram are for clear understanding of this. In your examination you will draw this diagram. And this is well bath, or this is a double wall chamber bath. By using this bath, no heat will come inside and no heat will escape outside, so that we can perform this experiment in a same temperature isothermal condition. And you know the different parts along with their function. Now you can describe in your own way, in your own words. I have kept the different apparatus and their function. Now let us move to the mathematical part, which is very important. If this is a spherical ball, or if this is a oil drop that is dropped from this atomizer, then this drop will experience one force that is called this weight, and another upward force that is called upthrust. These two forces are the natural force. If this oil drop moves downward with velocity v1, I have kept this v1 velocity, that is terminal velocity of oil drop, then the upward force will be viscous force, because we already know that if object moves downward, then upward force will be if the object moves downwards, then viscous force will be upwards. So in a equilibrium or balance condition, two upward force will be balanced by the weight. So weight is equal to upthrust plus viscous force. Now we already know that our expression for weight is 4 by 3 pi r cube rho times g, and upthrust is 4 by 3 pi r cube rho sigma g, and viscous force is 6 pi eta r v1. v1 is the velocity of particle in the absence of electric field. We perform this experiment in two cases, in the absence of electric field and in the presence of electric field. In the absence of electric field means we just switch off this battery, and we drop the oil drop from the upper plate and it moves to the down plate or lower plate. So in the absence of electric field we carry out this experiment and we equate these three forces, and then we will get the value of r. This is done in order to get the radius of the oil drop, and then our radius of the oil drop will be this 2 eta v1 divided by 9 rho minus sigma g. and this expression is important for us because we will use this experiment in another slide in the presence of electric field. Now in the absence of electric field, from this derivation in the absence of electric field, we got two important results, that is expression for r, expression for radius, and another is this expression 4 by 3 pi r cube rho minus sigma g is equal to 6 pi eta r v1. Now again we perform this experiment with electric field. Again the two natural forces are to the shear force are, the downward force is weight, upward force is upthrust. In this case we assumed that well drop is moving upward. We can assume that well drop can move because of electric force or because of these four different forces. We can consider well drop either moving upward or downward. Let us assume it is moving upward with terminal velocity v2. Then if it is moving upward, then its viscous force will be downward. So weight and viscous force are the downward force. Again for electric force we can assume that it either electric force either at upward or is downward. In this case I have assumed that electric force is upward. So two forces are in upward direction, they are upthrust and electric force. Two forces are in downward direction, they are weight and viscous force. This viscous force is downward in this case because with electric field, in the presence of electric field we have assumed that the object is moving upward, the well drop is moving upward, so viscous force should act downward. And then by writing all four forces we will get this expression, and then we can write this, we can bring this to this side, and then we will get 4 by 3 pi r cube rho minus sigma g, which is in fact 6 pi eta r v1, as we already I already mentioned that 6 pi eta r v1. And then after solving this and arranging this we will get the value of q, we will get value of q, and these are the different three results. This is the radius of well drop, this is the value of q. If well drop moves upward, then we will get this expression. If well drop moves downward, if we assume that well drop is moving downwards in the presence of electric field, then we will get this second expression, otherwise we will get the first expression. We can assume this both case in your derivation. So these three are the important result of Millikan's well drop experiment. Now after knowing this q, Millikan did this experiment for several type of well drops of different size, and he got this value of q. As all thing were known, as we know this all information, by writing this all information we get our q, and our q was this for different drop. For different drop we got this q. If we divide this q by 1.6 into 10 to the power minus 19 coulomb, then we will get integral number of integral number, that is n is equal to 1, 2, 3, 4 and so on. It proves that in well drop there are the basic quantity E is repeated in q of every well drop. That E is called basic unit of charge. That E is called basic unit of charge. In this way Millikan discovered the value of E, and he verifies, or he gave the concept of quantization of charge. This is the derivation of Millikan's well drop experiment. In upcoming video I will discuss different short questions and numerical problems. This experiment gave the value of E. This experiment gave the value of E, and J.J. Thomson gave the value of E by m. So when J.J. Thomson did his experiment, he gave the value of specific charge, and this experiment gave the value of charge. On dividing this charge with specific charge, we got the value of mass. Till this period mass was unknown, but after the Millikan's experiment and J.J. Thomson's experiment, we knew the mass of electron, that is E divided by E by m. We knew E by m and we knew E, and on dividing this we got value of this mass of electron, that is 9.1 into 10 to the power minus 31 kg. So main important of this experiment is to know the value of E, and with the help of this experiment we again knew the value of m. So thank you very much. This much for this Millikan's well drop experiment.